have to be wise. 5, 6, 7, 8, 9. So let's check 1, 2, 3, 4, 5, 6, 7, 8, 9. So we now have 9, which is non-name. We now have 6. That should be 6. Let's check 1, 2, 3, 4, 5, 6. So we have 6 and we have 9. So from our mind, first, before giving you hints on how to name this compound, try doing it yourself and see what you can do. And let's just go straight to the point now. So at this juncture, what are you expected to do? So what you are expected to do is to identify your parents' compound. So you know in our previous example that our parents' name, our parents' compound was based. When you're naming cycloalkanes, your parents' compound usually depends on the one that has more substituents rather than the one that has the longest continuous chain or unbranched chain. So when you're talking about the parent's name or the parent's compound, the parent's name is the one that has more substituents than the other. So anyone that has more substituents than the other will be the parent's name. So as you can see in this compound, if you take this compound as my parent's name, is wrong. Why? Because it only has one substituent. So since it has only one substituent, is wrong. But if I should take this compound as my parent's name, it will now have 3 substituents: isopropyl, methyl, and nonane. So this nonane, so I'll just replace that ANE with YL. So whenever an alkane group is acting as a substituent, you just replace that ANE with YL. So instead of calling this nonane, so I'll just call this what? Nonyl. So this nonyl, NONYL. So this is nonyl. Now I have this. What am I going to do now? So to name this compound, our parent's name becomes what? Cyclohexane. Since our parent's name is cyclohexane, which dimension should I start in writing this compound name? So if I should start from here, 1, 2, 3, 4, I will end up having my substituents in 1, 2, and 4. If I should start from the opposite direction, which is 1, 2, 3, 4, so I'll end up having my substituents as 1, 3, 4. So in naming compound, you usually give it the lowest possible name. So therefore, this is definitely out. So what you have is 1, 2, 4, because 1, 2, 4 is generally lower than 1, 3, 4. So in naming this compound, we are going to call this compound, dear brothers and sisters, whenever we see this, we call it isopropyl. But if you want to be like more specific in this isopropyl, we call it what? 1-methyl ethyl. So whenever you see isopropyl is called what? 1-methyl ethyl, or you call it isopropyl. So I'll show you why that compound here, this compound here, is called 1-methyl ethyl. So first, let's name this compound first. So in naming this compound first, I have my 1. So I'm going to name based on the green number, not by the yellow numbers. So I'm going to name this based on the green numbers. So to name this compound, I will call this was 1 isopropyl. 1. I think using the green will be more. So 1 isopropyl. What else do you have there? 4-methyl. So the green is attached to the 4. 1, 2, 3, 4. So you know methyl come before N in alphabetical order: A, B, C, D, E, F, G, H, I, J, K, M, N. So M comes before N in alphabetical order. So therefore methyl comes before nonyl. So therefore we're going to call this what? 4-methyl. Note that this should be methane, but since this is a substituent, it's acting as a substituent, so it has 1 reduction of hydrogen. So we're going to call this what? 4-methyl, not 4-methane. This is called 4-methyl. Now, where is this carbon atom attached? So next is what? 2-nonyl. Is 2-nonyl. Cyclo. Our parent's name, which is what? Cyclohexane. So this is 2-nonyl cyclohexane. So since you have this compound, 1 isopropyl, 4 methyl, 2 nonyl cyclohexane. So this is the name of this compound. So I'm going to explain this so it will not get you confused. This nonyl and this methyl. I want to emphasize something, but before I emphasize on this, let me first emphasize in this isopropyl first. So in this isopropyl, remember that I said is either you call this one, it's either you call it isopropyl or you call it 1-methyl ethyl. So the full name, whether you write it in this manner or this manner I'm going to write, both of you are also still correct. But if you want to be more specific, so you go ahead and write this name 1,1-methyl ethyl. So an isopropyl is definitely called a methyl ethyl, 1-methyl ethyl. Okay, let me explain. Isopropyl, let's draw the structure of isopropyl. The structure, let's expand it. The structure of isopropyl is this. So what is our longest chain here? Our longest chain here is definitely propyl, which you see here 1, 2 and 3. So this is propyl. Now we have propyl. There is no substituents. So going that way is wrong. So what I'm going to do is, since my end product or my main product or what I'm expecting to get is an substituent, so what I have to do here is to call here my 1, call here my 2. So like this is just called isopropyl. So to name this compound appropriately, you just call it 1-methyl ethyl. So the full name of this compound will now be 1-methyl ethyl, 4-methyl, 2-nonyl cyclohexane. Now let's emphasize on let me clear some space. Now let's emphasize on these substituents, which I said the methyl and the nonyl. So you know in nonyl has this structure CH3 1 2 3 4 5 6 7 8 9. So nonyl have this structure. So this should have ended with CH3. That should have ended with CH3, but it ended with what? CH2. So there's a reduction of 1 hydrogen atom. This was called, that is why we implicate that name was nonyl. It's ended with we remove 1 hydrogen atom in order for, you know, carbon is always in this format. It is always 4. It is always tetra. In order to obtain the octet, so carbon is 4 in the group 4 is located in the group 4. Carbon is found in group 4, so it requires more 4 covalent bonding of another compound in order to acquire 4 electrons. For it to acquire these 4 electrons and obtain the octet, so it will be balanced, so it stop reacting. So it usually bring 4 valence share for bonding, 4 covalent bonding. So this is now CH2. So why is that CH2 instead of CH3? Now let's see this diagram very well. So that should be C hydrogen with another hydrogen, which we know. But carbon now loses the hydrogen and uses that bond to bond to this alkyl group this cyclohexane as a parent name you are seeing here. So it loses that one hydrogen in order to bond with this, because if this hydrogen was here, it will not be possible for this carbon to bond because it is now filled. So it have obtained the octet rule. So what this carbon has to do is to remove this hydrogen. So in the process of removing this hydrogen, we now, so since it has one reduction of hydrogen, we now call it what? An alkyl group. This is the reason why we call it an alkyl group, and we change that name from nonyl ANA to YL, which is nonyl, because of there is one hydrogen is out, so it uses that space in order to bond to this cyclohexane here. So I hope you have understand why we changed that name. Now, what of the methyl? If you come down and observe the methyl, the methyl, methane generally have CH4. This is methane. This is methane, we know. So this is methane, we know. So this methane loses one and forms CH3. We now call it what? Methyl, because one hydrogen atom is out. So since one hydrogen atom is out, so this one hydrogen atom, which is what? CH3, it will now use this for bonding. So carbon will have a structure like this: hydrogen, 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 and this is now used to bond to an alkyl group. So let me draw this so you understand. So this methyl, I'm going to clean it now. Let me expand this methyl. So expand this methyl, we now have C, hydrogen, hydrogen, and what? Hydrogen, which is what? CH3. That's why we call this methyl. So it loses that one hydrogen in order for it to gain space and bond with this carbon here. So I hope you have understand these principles. Now let's